Earth is about to be deleted from the solar system. A rogue planet, traveling at 50,000 miles per hour, is on a collision course with our home. No atmosphere, no sunlight, just a billion tons of rock about to reset history. Can we survive? Let's find out. The rogue planet collision, the final impact. When the rogue planet finally reaches Earth, the last few minutes would be unlike anything humanity has ever experienced. This would not be a normal asteroid impact, and it would not be a simple collision between two solid worlds. A planet carries an unimaginable amount of mass, and when two planetary bodies collide at enormous speeds, their kinetic energy would be released on a scale that is almost impossible to visualize. The first signs would begin before the worlds even touched. As the rogue planet approached, its immense gravity would begin pulling on Earth, disturbing the oceans, atmosphere, crust, and even Earth's orbit. The closer it came, the stronger the gravitational forces would become. The oceans could surge into enormous tidal movements, the atmosphere could become violently disturbed, and the surface could experience stresses far beyond anything modern civilization has ever faced. Then, in the final moments, the two worlds would finally meet. The collision zone would instantly become an environment of unimaginable pressure and temperature. Rock wouldn't behave like the solid ground beneath our feet anymore. Under those extreme conditions, enormous amounts of material could melt, fracture, and vaporize. A gigantic shock wave would race through Earth's interior, while superheated rock and debris would be blasted high above the atmosphere. The impact would send material thousands of kilometers into space, creating an expanding cloud of molten fragments and vaporized rock. From space, Earth could begin to resemble a glowing ball surrounded by a massive cloud of debris. The atmosphere would be overwhelmed by the enormous energy released during the collision. Temperatures around the impact region could become extreme enough to melt or vaporize surface materials, while the shockwave would travel across the planet. Oceans near the impact zone could be rapidly converted into steam, and enormous quantities of water vapor could be injected into the atmosphere. The sky would no longer look blue. Instead, the atmosphere could become filled with glowing debris, dust, vapor, and superheated gases. Continents would be fractured and buried beneath enormous amounts of ejecta. Mountain ranges could be destroyed or partially melted. Vast regions of Earth's surface could become molten, creating enormous pools of magma where solid landscapes once existed. But the most terrifying part would be happening above the planet. The collision could throw enormous fragments of Earth and the rogue planet into orbit. Some debris might eventually fall back toward the surface as an intense global bombardment, while other material could remain in orbit,